This is question Q2b. We continue with plotting the DTFS and the DTFT magnitude and phase representation of this discrete time signal. We begin with xn, and then now we find xk as in the previous example simply by using FFT of xp, where xp is one period of this sequence. We find that we only need capital N equals to 24 samples. And once we have that, then it is very easy to find CK. CK is the DTFS representation, and it is simply 1 over N times xk. Then the rest is just plotting. So we only simply need this equation. Let's see my code. So the DTFS is nothing but 1 over N times xk, and xk, remember, is nothing but FFT of xp in the previous slide. Right. In this example, I'm going to plot the double-sided, so I need k-shift. K-shift will go from minus n over 2, which is minus 12, to 12 minus 1, so it's 11. So I'm going to plot from 0 to 11, 0 to minus 12. And the 0 is in the middle, so 0, 1, 2. The third coefficient, the fourth coefficient, the minus 1 coefficient, minus 2 coefficient, minus 3, minus 4 coefficients. So this is C3, this is C minus 3, and we are plotting the magnitude here on the top. So the magnitude is half. So the only difference between them is the phase shift. So we are 0 here, 1, 2, this is 3, and this is minus 3. So we have minus pi here and pi. So C3 and C minus 3, the phase shift shows us that C3 is actually the, which one? The sine. Okay? C3, the frequency at C3, the third harmonics is of course a lower harmonics. So actually this is what? 0. How many? 0.25 pi rotating. This is 0.333 pi rotating. So this is a higher frequency, this is a lower frequency. In the horizontal axis, remember, this is as we go up the index, the higher frequency. So C4 is higher frequency, C3. Alright, now we're going to plot the DTFT representation. In the DTFT representation, the magnitude is multiplied by 2 pi times CK. So originally, the magnitude is half. Half times 2 pi is pi. So this is 1 pi. Okay, that's all we're plotting here. And the difference between these two is not only the magnitude. Here is the arrow showing that we are using the delta function. Okay, the reason is because actually along omega, we should be plotting all values. But since these are all pure sinusoids, and we are taking the Fourier transform, only these frequencies C3 and C4 at these particular frequencies are needed. The rest are 0. Alright, so again, we also do the phase. Now, what is this frequency over here? And what is this frequency? This is actually k equals to 3. When k equals to 3, omega is 2 pi over n times k, 2 pi over 12 times k equals to 3. So this is pi over, sorry, n is 24. So it's 2 pi over 24 times 3. So we get pi over 4. And the other one is 2 pi over 24 times 4. And we get pi over 3. So therefore we now know that these are the equations we use to find omega. Okay? Alright, with that, I think you can study the code and how I get from, what do you call that, the xk, which is the DFT coefficients, into the DTFT coefficients. Alright, with that, thank you.